So here is the course plan that what we have designed. Okay, so this is not going to be the final. I'm gonna add few more topics to this batch. So as I promised. So initially we'll start the batch, discussing about what exactly big data is all about, and then what problems we have in the legacy systems, why we have to migrate to big data, and then in what way, like big data provides solution to the problems that what we are facing currently in various legacy projects. So and then big data is famous, like it can store huge amount of data. There is no limitations of amount of data that it can store. And then and it can process the data using different tools and techniques. So I gonna take you, like into the HDFS architecture, Hadoop Distributed File System, which will help you to understand like how big data stores that massive amount of data. And then, since it's a distributed file system, okay, we will learn about various Hadoop commands to interact with Hadoop file system. So there is a slight difference between the commands which we use to communicate with the local file system and the Hadoop distributed file system. We'll see about those commands as well. And then we will set up our own environment in your laptops. Like we set up the Hadoop environment. We use a Cloudera Quick Start virtual machine in order to get a ready-made, a vanilla flavor Hadoop environment, just to kickstart our hands-on experience from day one. So and then we start with the data ingestion first. To like 30 to 35% of the big data projects are or their initial stage, initially it starts with the data ingestion. So the data in the legacy systems has to be moved to Hadoop first, and then the data can be analyzed. So analytics on the data cannot be done on the external systems using Hadoop technologies. If you want to analyze the data, if you want to perform some operations on the data, first the data has to be available in the Hadoop cluster. So the way how we bring the data from the external systems into Hadoop cluster, okay, so that the concept is called as data ingestion. And then as a part of data ingestion, we have two different services provided by Hadoop stack. We have Apache Sqoop, we have Apache Flume. Sqoop, we use it to bring the data from the traditional RDBMS databases into Hadoop. So we'll scoop the data from different databases and then ingest into Hadoop cluster. So that's we're gonna see like how it can be done in the concept Apache Sqoop. And we're gonna see, like how the log data, the streaming log data can be ingested into Hadoop cluster, and then can be performed analytics on the top of that data, so using Apache Flume. So once we are done with the data ingestion, we believe that that we have some data available in Hadoop cluster, and now it's time for us to start processing that data and then do some analytics on the top of that. So to do processing on Hadoop data, we have different services available in Hadoop, different techniques. So we have MapReduce, we have Apache Hive, and then in MapReduce we use Java coding in order to process the data, and then we use Apache Hive. It's all SQL programming, and then we have big scripting. And also, like once we have dealt with multiple topics, like how we can process the data, then we will design an automatic workflow, because when we run our projects in the production environment, okay, we need an automated workflow that has to be scheduled so that, okay, in real time there is no manual intervention to run our projects. So we are going to look into like how a workflow can be designed through the concept of Apache Oozie. And then we will deal with the advanced concepts in Hadoop area. So one such advanced concept is Apache Spark. You might have heard about, like the importance of Spark in the projects. So instead of doing the processing in the secondary storage, okay, so the key characteristic of Apache Spark, it do the processing in RAM. So that is why it is called as in-memory processing. Because of in-memory processing, Apache Spark can help us to run the queries, much for 100 times faster than the traditional way. So we will see, like, what is the architecture of Spark and how it improves the performance of processing the data. And but in Spark programming, we're gonna use either Scala programming language or Python or Java. So since Spark is actually built on Scala, so I'm gonna teach you what is Scala programming. We will spend some time on it. I will help you to gain knowledge on hands-on knowledge on Scala programming. So once we dealt with that, okay, we'll start developing the Spark programs using Scala throughout our session. So, and then in Spark, we have Spark Core, we have Spark SQL, we have Spark Streaming as well. Of course, we do have machine library algorithms and then graphics, but of course, we are not getting into that lane. So we will focus majorly on Spark Core, Spark SQL. If time provides, okay, we'll look into the Spark Streaming as well. So we have Apache has its own messaging queue, something like Oracle Service Bus, something like IBM MQ. So we have something called as Apache Kafka. Kafka is a messaging queue introduced by Apache. So we're gonna look into these Kafka concepts, because that will help us to understand in real time, like if we have multiple sources pushing the data to a single destination or multiple destinations, doesn't matter. How can we ensure that the data transfer will be reliable without any data loss? How can we ensure that the consumers who is waiting for a particular data packet from a particular producer, how much reliable is the data transfer is all about? So we look into all those concepts, okay, through the Apache Kafka. And then I want to make you guys feel advantage of joining this session. So I want to spend some time to teach you some advanced concepts, like one of the NoSQL database named MongoDB, and I want to teach you what is Apache NiFi, and then we will do some sample examples in Apache NiFi as well. So we do some hands-on development in that, because Apache NiFi is one such tool currently being used by many IT organizations for a easy data movement. So it has an ability to move the data from point A to point B. So let the source be anything, the destination can be anything, doesn't matter. So through Apache NiFi, you could move the data. It can perform a limited amount of transformations on the data. It's not an ETL tool, but it will definitely help us to move the data from any source to any destination. So we look into Apache NiFi as well. So along with all these topics, I will, as I promised, okay, I'm gonna bring my experience into the picture. I'll share my knowledge, my project experience knowledge, whatever the projects that I have worked so far in the last 5.5 years of big data space. I'll bring that my knowledge into the picture. So that will definitely help, because maybe majority of you people, like, maybe working in the similar kind of project scenarios in future. So you may use the solutions that what we have developed, and then that will definitely help you. And then for each topic, like Apache Kafka, Spark, Sqoop, okay, for each topic, okay, I will help you to do some POCs on the top of that. I'll give you an objective, like what has to be done. I'll give you a sample data set, and then I will request you guys to, I'll give you some necessary guidelines, like, how those objectives can be met. And then I will guide you guys to build the code, to do some data analytics on those input data sets. And then in that way, like, you will gain much more confidence by doing the hands-on for every topic in Hadoop. So that's all I have with the Hadoop course curriculum. So I'll take the questions from you guys once I've done with the Hadoop introduction. So starting with the Hadoop, so I think you guys might have heard a lot about Hadoop, but so have you done any groundwork? Like, do you have any understanding what exactly Hadoop is all about? And then can you guys help me out what you have understood about Hadoop? Parvez or Binod? Can you guys help me like to understand what is Hadoop? Why do you think like it is so prominent and famous in the market now?
Like I said, I have no idea about Hadoop is. This is the reason I'm here.
Okay, okay.
I also want to know about big data that I saw in your previous slides. It says, what is big data? That is exactly my question is,
I'll take you into that. Yeah, sure. I'll help you with that. No issues. I just thought like some associates, like, they generally do some basic groundwork when before they choose a particular technology that they want to learn. So in that context, I just want to hear like what do you think big data is all about, or something like that. That's the reason
Yeah.
like I have asked. Okay, so I just want to make this session as much interactive. Even so most of my sessions, okay, it won't be like I will go through the session completely for 1 hour, and then I'll take only the questions and answers only at the end of the day. It's not like that. What I used to do is, okay, like I'll complete a topic for every 5 10 minutes, and then I'll take a pause there. I'll consider it as a checkpoint. I'll hear the questions from you. I try to rectify each and every question that everyone has in the batch, and then once we have completed with that, then I will move on to the next topic. That is how I work. So I'll keep a checkpoints at regular intervals of time, and then we can proceed accordingly. I'll help you with that, Vinod.
Yeah,
Yeah,
Srikant,
Parvez,
yeah,
yeah.
yeah. Um, so it's more like a ecosystem where we deal with a huge volume of data. That's what we call as big data.
Hmm.
And uh, how do we actually store the data and then how do we process it? So it's all done on the Hadoop environment. And just a very basic overview.
Correct, correct. Okay. So whatever you have explained is correct, Parvez, but okay, I'll add bit more information. I mean, like, detailed information to the definition that what you have given. So might be your answer is very crispy and clear, very straightforward. uh, but let me help other associates, okay, to gain much more
Yeah.
knowledge on this. Okay, so what exactly is big data is all about? So people think that big data is a different concept or a different technology, or it's nothing, none of these. Okay, it's all about, it's just a normal usaged English word. Okay, so it says that it's huge amount of data. That's it. Big data is all about huge amount of data. And then so when I say huge amount of data, if you want to calculate, like, in what way, that how you can measure the amount of data, okay, so it may be typically in terms of hundreds of gigabytes or terabytes or petabytes of data. Okay, so we don't consider, for example, if I have 2 GB of data in my with me, if I have in data set of, for example, of 5 GB or 4 GB, I don't typically want to say it as a big data in real time, because I don't use big data technologies in order to process, do analytics on this small file, like 4 GB or 10 GB. Typically in the big data world, okay, we call terabytes and petabytes of data, the projects where we have terabytes and petabytes of data, uh, we call it as big data, and then we use big data solutions in order to solve different data problems with those big data, what they have, big data sets what they have. Because I don't think, like, in something, uh, to keep it simple, like, okay, we don't use so technologies in big data for a simple small data sets. Okay,
I
so
have a quick question, okay, if you don't mind.
sorry.
So, quick question I have.
Please.
So when you said, big data is a huge amount of data, so
Mhm.
where we store these data? Like, is there any server or is it cloud based?
Okay, yeah, so you want to know where exactly it will be stored?
Correct.
Okay, so
Like we're talking about terabytes or something, right?
correct.
Petabytes.
Yeah, we are going to see that in couple of slides. We are going to see
Oh,
that in couple of slides.
okay, okay.
We'll get into that. Just hold your anxiety for a couple of minutes.
Okay,
I'll definitely help you to get your question answered. Okay.
okay, sure, sure.
So sorry to block you there. Okay. Yeah. So we have various sources of big data. If you think like from where this data is getting generated, there may be different areas. We may have retail, we may have banking, insurance sectors. We have different areas in the market, different types of customers, different types of projects working on. So, but what is the major source of this data is getting generated? Data is everywhere. Data is like we consider the data is there only in our hard disks. We consider it like only the multimedia data, like movies, the photos, whatever we take it and then we store it in a hard drive, and we want to do some analytics on that. It's not that. Data is everywhere. If you take a banking customer, for example, so all the transactions that their customers will do, it's a data, right? And the bank has to do analytics on the recent transactions what the customer has done. And then if you see, so you will get alerts like you have some apps in your mobile that can track your recent transactions like purchases, and then the bills that what you have paid and all. And it will give you a summary, it will give you a report, like, Shrikant, you have spent $1,000 in the last 1 month. Seems to be like, okay, your earnings, your spendings are much higher than or close to your earnings. Okay, please make sure that, okay, you maintain sufficient funds in your account balance. So I'll get some suggestions, I'll get some advices, or something monitoring is happening on my data, on my transactions. There are different how these all analytics are happening. Of course, I'm just doing a transaction, but the applications that runs on my on the data with respect to my transactions, like all the transactions of all the customers in the bank, will help the customers to gain information about, or to gain advantage of various services being provided by the bank, right? So uh, if you see, okay, let's focus completely on the sources of data rather than discussing about applications. So we have data generated from various sensors. If you see, now it's all about IoT world. So we have information everywhere. We have data everywhere. We have IoT sensors, data getting generated from every uh, traffic signals. If you have, for example, if you take a flight journey, every 1 hour of flight journey, every flight has a black box, so you know that it holds too much of information and with respect to that flight journey. And then if you take satellites, the amount of data that the images it will capture, it will send the data, it will store the data into the massive servers. And we have weather reports. You will see the forecast about the weather, like that it is going to rain tomorrow, like it is going, we have a snowfall in the couple of days, how those predictions can be made. And then how much percentage of snow is expected, how much percentage of rain is expected. You're gonna, everyone, okay, using the weather app, they can see the forecasting information about the weather. So how these analytics has been performed, from where this what is the source of uh, data for doing those weather analytics. And also we have information everywhere. So various, I just listed out only few sources of big data here, but this is just only an example. There are too many areas, like everywhere we are getting data generated. So only thing what we have to do is, okay, we need a solution where I can store this huge amount of data. If you take a traditional database like Oracle, if you take a traditional database like MySQL or SQL Server, so for example, even if you just go for a your own hard disk, okay, your own laptop. For example, Binod, you have a laptop of 1 terabyte storage capacity, and you store some data into your this one into your laptop, and then you have much more data. For example, you have some more videos to be copied into your hard disk, and you don't have enough space in your hard disk. What will you do? You'll go for cloud storage, or you will buy an external hard disk of 2 terabytes or 4 terabytes, and then you'll dump your data into that.
Right.
And what if after 2 months, okay, even if your external hard disk is full, you'll buy one more, right? What if, like, you don't want the manual intervention happening like this. You want the automatic scaling of your storage capacity has to be done. Someone has to monitor, someone has to take care. For example, people who go for cloud storage, they will pay for the service that what they are using, and then any amount of data that they store into the cloud, okay, the scaling of the cloud storage for the particular customer will get increased automatically, isn't it? If he is paying for that, right? So in real time, the amount of data we store in a particular storage, if it is full, then we will expand the storage space, and then we'll expand it again, and then again, and then again. So Hadoop, okay, it has its own architecture, the way it has been designed. It majorly addresses two different problems. Not majorly two different problems. It majorly addresses three different problems of big data. So they are nothing but volume of data, velocity of data, and then veracity of data. When I say volume, it's nothing but size of data. As we know, like since we have multiple sources of data, data is getting generated at a rapid pace. Data is getting generated massively. For example, if we just take Facebook, the number of messages that we post on our wall increases day by day, isn't it? We post videos, we share videos, we post multiple um, photos actually on our timeline, and we share multiple things. We do chatting, we do text messages, we play games in Facebook. What is the amount of data that is getting generated by every customer? It increases massively. Today, for example, if Facebook, all the customers in Facebook, they generate 1 terabyte of data, will it be the same for after next month? Maybe after a month, okay, the amount of data we'll generate, it will be like close to 1.2 terabytes. But will it be the same case after 6 months from today? I can definitely expect, like, that it will be more than 1.5 terabytes or 2 terabytes of data, because number of users who is using Facebook is growing. The amount of data that they generate will also grow. So the volume at at I mean, like the speed at which this volume of data is getting generated is also high. So the speed is nothing but velocity. So we have one problem is the size of the data. The second problem is the speed at which this data is growing, is being generated. And the third problem what we have with big data is veracity of data. I mean, we have different types of data. One is structured data, or semi-structured data, or unstructured data. So irrespective of the type of the data, still we could able to store it, we could able to process it, and then do analytics on the data, isn't it? So if I say that, okay, big data or Hadoop framework is a solution that can process only structured data, do you think it's a right statement? How many big data problems that it is going to provide solution to? I don't think so. Like, like it can address only one group of projects. But Hadoop is not only Hadoop capability is not going to end with that. So it can process, it can store, and it can process different types of data. Like, it can store semi-structured data, structured data, and also unstructured data. Hadoop has capability to store any kind of data, any type of data, and then it can process any type of data. It has its own tools to process the data, any type of data. Okay, so that's one thing that what I would like to say. So we have various challenges. Like we have, as I said, like we have volume, velocity, and veracity. Okay, so to address all these challenges of big data, Hadoop framework came into picture, and Hadoop has its own architecture. It provides majorly two different services. So one thing, it can store a huge amount of data. The other one, it can process big data. So when it comes to storage, Binod, you have a question where Hadoop will store the data and how it will address the big data problems, challenges. How it can, I mean, like we have volume, huge amount of data, right? And different velocity and veracity of data. How Hadoop is capable of handling all those data challenges. We're gonna learn through the concept of HDFS architecture. We have Hadoop Distributed File System. Hadoop itself is a cluster. It's a cluster formed. It's a cluster formed with set of nodes. When I say node, it's nothing but an individual computer. I'm like individual a node that has capacity of storing the data and processing the data. Okay, so if you Hadoop itself, it has its own cluster formed by set of nodes together as a single network, and that particular cluster has the capacity of storing the data and then to run the processing logic on the top of the data to do some data analytics. So how this architecture has been designed, how this cluster has been set up, all those things we're gonna discuss in the topic called as HDFS.
Okay. So in terms of storage capacity, there is no limitation, right? It's unlimited.
Correct. So you can scale your cluster at any point of time. The maximum number of nodes as in Hadoop, we are currently using Hadoop 2 architecture in the market. Till 2011 and 12 we have Hadoop 1, and then later Hadoop 2 came into market. The maximum number of nodes that Hadoop 2 architecture can scale up to is 10,000 nodes. So each node can have it's up to you. Like it may have 1 terabyte hard disk or 10 terabytes hard disk or 1 petabyte hard disk. It doesn't matter, depending upon the amount of money that you want to invest on your cluster. I mean, like your customer, your client will invest on the customer. Because if you take, okay, in my project we maintain a 45 node cluster. So okay, where each node has its 10 terabytes of storage space, and then we also have 1 terabyte of RAM. Depending upon the infrastructure that what my client is ready to set up for my Hadoop cluster. Okay, but the maximum scaling capacity of a Hadoop cluster is up to 10,000 nodes.
Okay, Srikant, so who owns this cluster? Is the Hadoop company?
No, sorry. Anyone can build their own cluster. For my project, we built our own cluster, and then we store our business data into that. We do analytics on the top of that. So you might be working for a different client. Your client will definitely set up their own cluster. If he is not interested or willing to set up his own Hadoop cluster, he can go for cloud service. Like he can depend upon Amazon or Azure cloud services. Okay, there are, and then you can pay. I mean, like you can set up your Hadoop cluster over the cloud, and then you can make your you can perform data analytics on the top of that. You can provide a necessary user access to your teammates, and then you can allow them to store the data and then do analytics on the top of that. Physically, you don't see an infrastructure in your office because it's all available in cloud. But my client, okay, so they decided to set up their own cluster. They have not gone for cloud service. They have invested some amount. They set up their own cluster. They are doing. Of course, any organization, they don't let their business data to go out of their office, right? Isn't it? It's all their privacy of the data. So any data analytics that they want to do, they will set up the cluster within their organization, and then they do analytics on the top of it.
Right.
We never give. We never give someone to gain access over our cluster. Okay, so no one will take our cluster into control. It's we who has to maintain our own clusters.
Okay.
Okay, and then any data that we store in Hadoop, if you and then once if you want to process it, so as I said, like we have different processing techniques like MapReduce, Hive, Pig, Spark. Different concepts are there in Hadoop. We're gonna see into each one of these in detail with hands-on examples in our course. But all these processing approach, okay, so their underlying architecture, their underlying concept is nothing but MapReduce. So though we run a SQL query in Hive, though we execute a Pig script or a Spark program, in the back end, in the background, okay, so these programs are converted into a MapReduce program, and they will execute it as a MapReduce jobs, because the actual processing in Hadoop has been designed as a MapReduce job. So what is mapper, what is reducer, what is a MapReduce job, and also we're gonna learn it, okay, through our course later. So if you see some of the terminologies, okay, so the concept MapReduce, it's not newly invented by Apache and also earlier. It was initially the same MapReduce processing approach has been used by Google, and then Hadoop also use the same. Google has its Google file system. We have Hadoop file system. They use their own NoSQL database called as Bigtable, and we have Apache have their own NoSQL database, something called as HBase, which is added as one of the service in the Hadoop ecosystem stack. And we have monitoring agents like Zookeeper, which is similar to Chubby in Google. So some of the keywords that what we can make note of, and different types of roles. Like after completing this course, what roles that you will be best fit into, like what roles are available in the market, or what roles that you will best fit into after learning the topics from this course. So typically you can become a Hadoop developer or a data analyst. That's what our main objective is all about. So the entire course, all the concepts that we're gonna see, we're gonna learn, it's related to Hadoop developer and data analyst. We are not dealing with any admin stuff. Of course, I will help you out, guys, to set up your environment and some of the services and the configuration parameters that we have to now and then, like wherever it is required for each topic, whatever may be the configuration parameters that we have to change in Hive site.xml or HDFS site.xml, doesn't matter. So in Hadoop files, so I'll help you with to understand, like what admin in generally do, and how they will change the configuration parameters and all. We'll gain a very small knowledge on admin area, but majorly we will focus into Hadoop developer and then data analyst roles. So this Hadoop framework, this entire software, or is actually being provided by different distributors in the market. We have one leading Hadoop distributors like Hortonworks and Cloudera. Recently they got merged, like just a couple of months back, they both got merged together as a single organization. But ideally they are two big competitors before November 2018. So we have other competitors in the market like Mapr and IBM Big Insights as well. But as of now, we don't have IBM Big Insights separately. We have only Big SQL from IBM, but the rest of all, it has been acquired by other major giants. So majorly, we have only two distributors currently. Like we have Mapr as well, but being used by very few companies in the market. So majority of our hands-on, okay, will be done in Cloudera. So if you do hands-on in Hortonworks or Cloudera, doesn't matter. It's all same. Only the graphical user interface, how it looks like, okay, it will vary. But all the concepts that we in Cloudera or Hortonworks, it's all same. They're just the distributors. They're just the companies that provide the Hadoop software. But the topics beneath these softwares are all same. All Hadoop concepts are same. Okay.
Shrikant, so both are open systems, is it? Hortonworks and Cloudera?
Both are open source. Yes.
Okay, and we can.
That is yet another advantage that companies will look into, like that is the reason that why they migrate from their legacy systems into Hadoop, because Hadoop is open source. It can store massive amount of data, and it can help to do analytics on this data for batch processing or the real-time streaming data analytics. So they strongly feel that Hadoop is a very good solution for that.
Right.
So we basically has two different types of processing in real time. One is batch processing, the other one is real time streaming data processing. So batch processing is nothing but like set of jobs. I mean, we will run the jobs only once in a day or once in a week or something like that. We have all the data at one place, and we will run the job only once. Streaming data is not like the streaming data as it's whenever the data comes, the processing will happen immediately. One such example, if you take batching processing, if you see earlier, I transfer $10 to you, okay, or okay, so Binod transfers $20 to me. So earlier, what happens? Any banking transaction, if you make, it will take 24 hours to get credited into the recipient, isn't it? Even now, some of the banks will do the same for a interbank transaction. Okay, so Binod, if you transfer me some amount, I will receive the amount only after a couple of days, right? Why is that delay? Because when you make a transaction, your request will be holded in the queue, and then there are millions of customers who will do such kind of transactions every day. All the transactions, okay, there's a request will be holded in the queue, and all these requests will be executed once. I'm like at once on every day. For example, every day morning 9 o'clock, this batch will get triggered, and all the requests in the queue will get processed at once. But if you take, that is called as batch processing. If you take a real-time streaming data, for example, if you take when you are watching the cricket match, or when you're watching any American football match, you know, whenever there is a touchdown in football, or okay, whenever there is when the player makes a point, or if you just speak about cricket, okay, whenever the player hits a 4 or a 6, okay, so immediately the run rate, the average, the economy rate of the bowler, the run rate of the batting team, everything will get changed. Those numbers will get changed immediately. When there is a change in the score, immediately these values will get changed. So which means whenever the data gets changed, some processing happens on the data, and then immediately the other values also will get changed. This is called as real-time streaming data. The data will be continuously generated, and then immediately the processing applies on the top of that, and the results will be generated. So we have both the kind of projects in the market. So big data is capable of handling either of the, so both of these. So it is capable of handling batch data. It is also capable of handling real-time streaming data. You'll come to know much more. These are some of the examples, but when we go deal with the different projects, you'll understand. Okay, what kind of data you are going to process? Is it a batch or is it a real-time?
Okay.
Okay.
And Shrikant, the way we set up our virtual machine, right, on Cloudera. So similar way we can do it for Hortonworks also. Is that
Exactly. Everything is same. It's just a software from a different company. That's it. But both are same. Only
okay?
the graphical user interface, the look and feel will change.
Okay.
But everything is same.
Okay. Got it. Thanks.
The Hadoop commands you use, the services what you use, the Hive programming, map reduce jobs, everything is same.
But sometime back you mentioned, right, 2018 end they merged both the companies, right? Is that
Correct. So recent mergers, the recent two, just a couple of months back, these two companies got merged, but still their services are ideal. I mean,
okay?
only
Okay.
see Cloudera, whatever they have spent some time for the last decade, they developed multiple services. It remains the same. Similarly, whatever that Hortonworks have done, the same. Only the organization heads, the companies, their shares together, they brought it together, but the services what these companies provides, okay, it still remains same. You understand?
Yeah. Thanks.
Yeah. So with this, okay, I'll take a break for the introduction. Okay, I hope you understand it, like what exactly big data is all about, why we have to use this, where it will be used, and then how we will store the data, and then analyze the data, and all those concepts. We will definitely look into those concepts once we kickstart the batch.